I'm Edie Lush, and I'm here inside the Hub Culture studio with Josh Tenenbaum. Now, let me see if I can get this right.
Yeah.
We've got brain and brain and cognitive science. I've already screwed it up. We've also got artificial intelligence, computer science laboratory, MIT,
Yes.
the core, Quest for Intelligence,
Yeah.
scientific director. I think I've got at least...
We've got a lot going on.
So tell me, you know, the discussions in Davos this year are all about the fourth industrial revolution. They're all about machine learning, about artificial intelligence. But what is this intelligence that we're actually talking about?
Right. So I think what people are calling AI right now at Davos and in the industry leaders that most of the world is aware of is a very powerful kind of technology that people also, it's the same as machine learning, neural networks, and deep learning. It's an approach to doing something that we used to think only humans could do, and now machines can do it, right? And this has led to all sorts of amazing technologies and will continue to do that. But there's an important sense in which it's not what we in academic AI call real AI, right? It's not what the original dream of the people who invented AI is about, which is about understanding how humans think and learn. Think of what we call AI right now in industry are, think of them as like the kind of mathematics needed to capture the most basic animal learning processes. They're equations that were worked out by scientists in the 1970s and 80s for the simplest kind of learning, like think Pavlov's dogs,
Right.
or a rat in a maze, right? That's finding patterns, associations, but it's not really understanding, right?
Yeah.
And thus it's not real intelligence. So I like to ask, and what we ask in our research is, what would it be like if we could write down the simple equations, or maybe not so simple math, to describe how a child learns, right? It's in some sense AI's oldest dream. Could we build a machine that grows into intelligence, human level intelligence, the way a child does, that starts like a baby and actually learns the way a person does, right? That's not something that we're ready to do, say, at the scale of the tech industry. It's not going to show up in business in the next couple of years. But amazing progress is being made, and when you reflect back on the history of AI, that what's really having an impact today in all these places we see around us in Davos is based on basic neuroscience, brain science, and cognitive or psychological insights from decades ago. Then we've seen that even small steps, when scaled up, can change the world. So imagine what could happen with the next small steps.
So tell me about one of the projects that you're working on that illustrates just that.
Yeah, well, think about the remarkable human ability that you can see in any young child to learn a new concept, not from hundreds or thousands of examples, the way today's AI does in industry, but from just one example. We can learn thousands, tens of thousands, hundreds of thousands of new concepts. So you see this when you're learning a word, right? Like, how does a child learn the word dog from just seeing one dog?
Right.
Or not just learning a concept, but how can you go to a real causal understanding? So think about the first time you saw a smartphone, right?
Yeah, which I didn't even realize was that big of a deal at the time,
exactly.
but it turns out it was.
It turns out, right? But just think about like the physical device, this glass screen that you can swipe your finger across and touch, and all sorts of stuff happens, right? Okay, so for each of us, there was that first moment when that happened, and it was just one event. You just saw somebody touch, swipe, and suddenly lights, and you understood from that one instance there was some kind of causal connection. And then you can also think, okay, it's not just a causal connection, but the person had a goal, what are they trying to do? And you start to actually understand this action and that causal connection. That's a very basic common sense inference about how the world works and how human action works. It's how we really learn, right?
Yeah.
And right now, what we call AI doesn't learn that way, right? It has to, and again, I'm not trying to diminish what we have in today's AI. It takes increasingly bigger and bigger data sets and finds patterns in it in what is, in a sense, a much simpler, dumber way. So imagine what AI could be like if it could be smarter in this very basic human way.
But without bias, right? Because the problem with learning something from just doing it once is that you may not be learning in the smartest way, or you may be learning something that actually is quite harmful to something in the world.
Well, again, it's one of the things that we've seen is in machine learning, we have something called no free lunch. Some of the things that we think of as biases, right, they might be inevitable side effects of what we think of as intelligence, right? We see this in today's algorithms, and we might see this in other kinds of more human-like algorithms. And it might just be, and you might even be able to prove mathematical theorems about this, that there's just no way to make an inference that goes from the data that goes beyond the data. Because intelligence, whether it's today's AI or the future, it's all about generalizing, right? It's all about making predictions for things where you don't know the answer. So some kind of bias might be inevitable. But that doesn't mean that we have to be stuck with it, right?
Yeah.
So this is a distinctive feature of humans and human intelligence that's different from today's AI. Today's AI might get some bias in it because it was in the data set, and the AI itself doesn't know it has a bias, right? Humans have to look at it, figure it out, and okay. So just like we can look at ourselves, and again, we're not always good at it, but we can actually do it. We understand it's a thing to do, right? We can look at our own behavior or behaviors of others or our society or systems and understand, you know, that there is such a thing as bias, figure out how to diagnose it, and try to put in ways to fix it, right? So that's another part of intelligence, is understanding that you could be wrong, that you could have a bias, and having, you know, for example, one part of your intelligence debug another part. Okay, that's an important kind of intelligence that today's AI doesn't do. Humans do that. So we might ask, well, what would it take to build machines that could, in some sense, find their own biases, or in themselves or in other machines, and even debug them?
Yeah.
That would be nice.
Which is quite a human thing to do, and a human question to ask.
Right.
And just bringing it back finally to looking at how kids learn and how you apply that. Give me a little example of how you've seen that work in your work.
Well, I mean, as a father, I have a daughter who's just about to turn 17. I've seen so many examples. I mean, it's a remarkable thing about parenthood, right? Where you get to, in some sense, rediscover the entire world. I remember when my daughter learned the concept of a rainbow, right? Or the first time you see snow for the first time. So there's so many moments like that. In our work, you know, we actually do laboratory experiments with babies and kids, and we study some of the most basic common sense that's in any young child, but none of today's AI. So what we call intuitive physics, like imagine a kid like stacking up blocks, playing simple kinds of games like that, or when you're a slightly older kid, you know the game Jenga, with like one of the world's actually most popular games. So inspired by that, we've now actually built robots that can do these kinds of things, that use these common sense intuitive physics to understand the causality of how objects work, and we've even built a robot that can play the game Jenga, for example. Very cool. You might see that in the news in the near future.
Excellent, Josh. I love it. Well, thank you very much
so much
for stopping by the Hub Culture
Thank
studio. And I'm
Pleasure.
Edie
Thank
Lush.
Thanks.